Hi, this is King of Review. True or false? The equations y equals 3x squared and y equals 3x intersect at two different points. So one method for solving this problem is to graph each of these equations and then count the number of places that they intersect. We have a parabola and a line. So let's do that. Let's make a table of values for each of these equations and then plot the points on a coordinate plane. So we have y equals 3x squared and y equals 3x. We'll make a table of values. You could also use a graphing calculator to graph these. So I'll use the x values of 0, 1, 2, -1, and -2. I'm going to plug in each of these x values into the equation y equals 3x squared. I'll plug them in here and solve for the y coordinate. So when I plug in a 0, I get y equals 3 times 0 squared, which gives me 0. So the point 0, 0 is on my graph. When x equals 1, I get a y value of 3. When x equals 2, I get a y value of 12. When x is -1, I get 3. And when x equals -2, I get 12 for the y value. So let's plot this. So I have a coordinate plane here with an x-axis and a y-axis. Okay, so now I'm ready to plot these points. So the first point is at 0, 0, that's right here. We have a point at 1, 3, which is right here. We have a point at 2, 12, right here. There's a point at -1, 3, which is right here. And we have a point at -2, 12, right here. So I'll use these data points to draw in the parabola. So here is the parabola here. And the next thing to do is to get our x and y values for the other equation, y equals 3x. So I'm going to plug in the numbers for x, 0, 1, 2, -1, and -2. So when x equals 0, I have y equals 3 times 0, or 0. When x equals 1, I get 3 for y. When x is 2, I get 6 for y. When x is -1, I get -3 for y. And when x equals -2, I get a -6 for y. So now I'm ready to plot these points on the same coordinate plane. And I'll use red. So I have the point 0, 0. I have the point 1, 3. I have the point 2, 6. I have the point -1, -3, which is right about here. And I have the point -2, -6, which is right here. So now I can use these data points to fill in the line. So I have my line here. So where are the intersection points between this parabola and the line? Well, it looks like we have two of them, one here and one here. So the points 0, 0 and 1, 3 are the points of intersection. So there are indeed two different points of intersection. So this is true. Thanks for watching.